introduction to block diagram is there. You see
the last
that,
class,
only you can understand
we
what
have
is
seen
block diagram. Mathematical model of armature control DC. Okay, anyhow,
it's
it's
up to
not
you.
only that mathematical model for armature control DC motor, it is introduction to block diagram. System can be representation in block diagrams. This is a block diagram of a system. In this case, you see that G1 is a system. It is nothing but a differential equation. It has one input, maybe x1 is input and y1 as input. A subsystem, G1 is subsystem represented by a single differential equation. G2 is another subsystem represented by another equation, another differential equations. We have seen for a mechanical system has, if it has three masses means, then three differential equations will be there. You can draw three such blocks like this. For each differential equation, we will write one block. So this system made up of 5 differential equations. That's why 5 blocks are there. If you connect all these blocks like that, you can get the system. Because one output of the first subsystem is input to the next system. The output of this system is input to the another system. In other words, output of G4 and G2 and output of H1 are combined together and given as input to G3. Output of G3 is final output. In addition, the output is fed back. Like in a car example, we have seen a feedback. So this is the feedback path. This is another sub feedback path. If you combine all these things, you will get the entire system. We can find a transfer function C of S upon R of S. This is output C of S, input R of S. The Laplace transform of output upon Laplace transform of input is transfer function. Transfer function. We can find the transfer function by manipulating the 5 equations. How many equations will be there? For each block, one equation will be there. 5 equations will be there. If you combine all the 5 equations, you will get the transfer function like this. You have to manipulate all the 5 equations. Sometimes it's very difficult to manipulate 5 equations. In that case, if you represent in terms of block diagram, it can be simplified. That is called block diagram reduction. Here you can find C of S, R of S by reducing this block diagram. For that, 7 rules are there. Already we have seen 2 rules. The 7 rules today we'll see. Another thing, the first rule is, we'll see the first rule. If 2 blocks are cascaded like this is called cascaded blocks. 2 systems are cascaded. It means the output of first system is input to the second system. Output of first system is input to the second system. That is called cascaded system. If 2 systems are cascaded, then we can multiply the 2 transfer functions. If 2 systems are represented in time domain, say G1 of t, the output of G1 of t is input to the second system G2 of t. The input of the system is x of t, output of the system is y of t. If you want to find y, you have to convolute G1 and G2. Then only you can find y. The convolution is integral of minus infinity to t G1 of tau, G2 of t minus tau, d tau. This is in time domain. You know how it is difficult. You studied signals and system. That's why you know finding convolution of two systems, two time domain systems. Convolution of two time domain system is how it is difficult. It is in time domain. If you represent this in frequency domain, this will be represented as G1 of S, a transfer function. This will be represented as G2 of S in Laplace domain or frequency domain. If they are cascaded like this, then we can simply multiply. So convolution in time domain is multiplication in frequency domain. Converse also true. Convolution in frequency domain is multiplication in time domain. Already studied that. That's why multiplication is simple. Finding convolution in time domain is difficult. That is one of the reasons it is represented in frequency domain. The systems are represented in frequency domain. So if two systems are cascaded and if they are represented in frequency domain, to find the overall system, we can simply multiply the two blocks. That is first rule. Cascaded blocks with the transfer function G1 of S and G2 of S can be replaced by a single block with a transfer function equal to the convolution of transfer function of individual blocks. Convolution in frequency domain is multiplication. Convolution in frequency domain is multiplication. G1 of S multiplied by G2 of S. If two blocks are in parallel, second rule. If two blocks are in parallel, one block is G1 of S and another block is G2 of S. They are parallelly connected. They are summed together. The output of the two blocks are summed together. Input is same. The input to the first block and the second block both are same. But output is here X2 of S because different system. Here X1 of S. These two can be added, then you will get the final output if they are in parallel connection. Therefore, the equal transfer function is C of S upon R of S equal to C of S upon R of S equal to G1 of S plus G2 of S. They can be summed together. Parallel blocks with the transfer function G1 of S and the G2 of S can be replaced by a single block with the transfer function equal to sum of transfer functions of individual blocks. That is second rule. Third block. In the block diagram, you can say that this is called takeaway point. The output of G1 is given to G2 as well as G4. That's why this point is called takeaway point. Here, this is called a summing block. Summing block. All the signals, all the outputs are summed together. This is takeaway point. This is also takeaway point. Takeaway is simple connection, but summing is a summing block is required. Here also summing block. But here, because of the sign, the subtract. Even subtraction also can be called as summing. Positive value and negative value are summed together. You can say like that. So here, this block consists of two summing blocks and three takeaway points. Three takeaway points. If you want to reduce this to a, we'll see later. By using the 7 rules, we will reduce this to a single block, single transfer function C of S upon R of S. We'll find that. But to reduce that, we have to move this takeaway point ahead of block or sometimes before that block, like that we have to move. For that some rules are required. We should know the rules. So the moving a takeoff point or takeaway point to the right. So I want to move this takeaway point or takeoff point from 1 to 2, point 1 to point 2. Then only I can reduce the block diagram. If you want to move that, what is the problem here? This X1 signal is coming through this line to G1, G. The same X1 is going through this also. If you shift that, what will happen? Let us assume that G is gain. Simple gain, K. If X1 is passed through means it is amplified. So here we are getting without amplification. Here we are getting amplified by G of S. But if you shift that, the takeaway point is amplified signal. This is an amplified signal. So I have to reduce the magnitude by 1 by G of S. So that's why if you shift that point from here to here, then the signal should be multiplied by 1 upon G of S, because it is already multiplied by G1 of S. To nullify that G effect, I am dividing by G of S. Suppose the takeaway signal is one is amplified by G of S, another one is amplified by H of S. But you want to move the signal from here to here. While moving that, here it is amplified by G of S. I want to nullify the effect of G of S. That's why I am dividing this by G of S. That's all. This is possible in frequency domain only. In time domain, you have to do convolution integral. Therefore, to shift the takeoff point to the right of the block, divide the takeoff branch by G of S. That is the rule, third rule. Rule number 3. Suppose you want to shift the takeoff point to the left. Earlier, we shifted to the right. Here, we want to shift back. Backward shift. There we did the forward shift. Here, I want to shift the signal, takeaway signal from here to here. In that case, it is already amplified by G of S. The X1 of S is already amplified by G of S. Here, what you will get? Here, Y1 equal to G of S multiplied by X1 of S. But if you shift that, G1 of S will not be there. That's why we have to multiply again by G of S. Very simple arithmetic. But these are all we should remember. Then only we can reduce the block diagram. So it should be multiplied by G of S. Then only both will be equal. X1 and Y1 will be equal if you do like this. Suppose this takeaway point already multiplied by H of S means you have to multiply H of S and G of S. That's all. Then you can shift this point from here to here. That is rule number 4. To shift the takeoff point to the left of the block, multiply the takeoff branch by G of S. This is rule number 4. Rule number 5. Suppose you want to shift the summing point, forward shift ahead of the block, G of S. You want to shift. Then only you can simplify. But here, X1 signal is coming in. X2, X1 as well as X2 both are summed up. Then it is amplified. If you shift this point from here to here, what will happen? the signal x2 of s is not amplified by g of s. So what we can do is, if you shift, it is not amplified by g of s. That's why what we can do is, we can amplify that signal by g of s, then we can then both signal will be equal. Here what you will get, c of s equal to g of s x1 of s plus g of s x2 of s. Here also what you are getting, the same, c of s equal to x1 of s multiplied by g of s, x2 of s also multiplied by g of s, but here minus sign is there. So I should put minus sign. So here also you will get g of s multiplied by x1 of s minus g of s multiplied by x2 of s. Suppose the incoming signal is already multiplied by h of s, then you multiply both by h of s and g of s, because in frequency domain, two blocks can be multiplied together if they are cascaded. How you will add? If you want to add, this will be added like this. It will be added like this. It will be added like this. Two blocks. G1, H of S. It will be like this, like that. Instead of this. In that case, first rule says what? These two blocks can be multiplied together. That's why we can write G of S, H of S. Then what you will get here, in both blocks give the same output. G of S, x1 of S plus G of S, H of S, x2 of S. So both give same output. Therefore, rule number 5 is to shift the summing point to the right of the block, multiply the signal entering the summing block by G of S. Don't remember the rules. Just to think whether it is amplified or not. If it is not amplified, you have to divide. If it is already amplified, it means you have to multiply. That's all. That way you have to think. So up to 5 rules you can easily remember. The 6th rule is the opposite way, moving the summing block backward shift. If you do the backward shift, this signal is not multiplied by G of S, but if you shift here, it will be multiplied by G of S. That's why what we have to do to compensate that, here x1 is not multiplied by G of S, because it is multiplied, it is not amplified because it is added after the block. But if you shift the summing block before this block, what will happen? This will be amplified by G of S. To nullify the effect, we are done multiplying by 1 upon G of S. Therefore, the rule is to shift the summing point to the left of the block, divide the signal entering the summing block by G of S. Of course, if it is multiplied by H of S before entering the summing block, then the answer is H of S upon G of S. 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 These are the 6 rules. No need to memorize the rules. By looking at it, we can find. From my explanation, you can understand the 6 rules easily. What is the first rule? If 2 blocks are cascaded, just to multiply. The 2 blocks are in parallel, just to add or subtract, depends upon the sign. Third rule, shift the summing block ahead of the block after a forward shift. If you want to do the forward shift, what you have to do is, it is not amplified. It is not amplified. It is not amplified. If you shift that, it will be amplified. Therefore, divide. That's all. That signal is after takeoff. If it is multiplied by H of S, means multiply by H of S by G of S to nullify the effect of G of S. Second rule, if you shift before the block, backward shift, if you want to do the same effect, it is already multiplied by G of S. If you shift here, it is not multiplied by G of S. Therefore, you have to multiply by G of S. That's all. If it is multiplied by h of s, multiply g of s, h of s. That is fourth rule. Fifth rule, if you want to shift to the summing block, the signal is not amplified by g of s. That's why first amplify, then add. First amplify, then add. Similarly, if you want to move the block, summing block backward shift, it is not amplified by g of s. That's why divide by g of s. Divide by g of s. So you can easily remember the 6 rules. Seventh rule is different. Seventh rule is, it says R of s equal to R of s and C of s are input and output. You have to find C of s upon R of s. C of s upon R of s, you have to find. This is summing block. This is summing block. So let us call this signal as B of s. Feedback signal. Let us call it as B of s. What is the signal that we are getting here? What is the signal that we are getting here is E of s equal to R of s minus B of s. Am I correct or not? B of s. Here, what is the input to this signal? C of s. C of s. B of s equal to what? R of s. B of s equal to what? Input is C of s. Output is B of s. That's why we can write H of s, C of s. Can I write like that? H of s, C of s. What is C of s? C of s, let it be 1. Am I correct? C of s is the input. What is the transfer function for this block? What is the transfer function for this block? Output by input. What is output? B of s. What is input? C of s equal to the transfer function H of s. That is the definition for transfer function. What is the definition for transfer function? Laplace transform of output by Laplace transform of input equal to transfer function. What is the transfer function? H of s. What is the output? B of s. What is the input? C of s. Therefore, B of s equal to H of s multiplied by C of s. That's why I wrote, instead of B of s, I wrote H of s multiplied by C of s. Any doubt in this point? B of s can be written as H of s multiplied by C of s. Now, what is C of s? Output. The C of s is equal to the same way C of s. What is the transfer function G of s? Transfer function G of s equal to Laplace transform of output C of s upon E of s. Am I correct? Therefore, C of s equal to G of s multiplied by E of s. G of s multiplied by E of s. Am I correct or not? Because this is one transfer function. The output is C of s, input is E of s. Therefore, C of s can be written as G of s multiplied by E of s. This is second equation. Now, we can substitute E of s from the previous equation. G of s multiplied by, what is E of s from the first equation? R of s minus H of s, C of s. Or you can write G of s, R of s minus G of s, H of s, C of s. C of s equal to G of s, R of s, G of s, R of s minus G of s, H of s, C of s. You can bring C of s to the left hand side. C of s to the left hand side. Why the C of s is coming in the output? Some feedback is there. That's why it is coming. Feedback is there. The output is fed back as input to the system. That's why the C of s is coming. If output is coming, the right hand side means some feedback is there. So G of S, if you bring all C of S to the left hand side, what you will get? C of S plus G of S, H of S, C of S equal to G of S, R of S. G of S, R of S. Therefore, I can take the C of S outside. Therefore, C of S 1 plus G of S, H of S. 1 plus G of S, H of S equal to G of S, R of S. If you find the overall transfer function, what is the input? R of S. What is the output? C of S. We need C of S upon R of S. Laplace transform of output by Laplace transform of input. That is equal to C of S upon R of S equal to G of S. Right hand side, what we are having is G of S. R of side is brought to the left hand side. Only G of S is there. Left hand side, 1 plus G of S, H of S is there. That we can bring to the right hand side, G of S, H of S. Therefore, C of S upon R of S equal to, if this is the block diagram, it consists of two blocks like this, means this can be simplified like this. G of S upon 1 plus G of S, H of S. So here what we did is, this feedback signal is, the feedback signal is, this is the feedback signal. This is the feedback signal. This is the feedback signal. This is the feedback signal that is removed. And we got a simple transfer function G of S upon 1 plus G of S, H of S. What we have to remember here is, this minus sign we should remember. This minus sign we should remember. If minus sign is there in the formula, what you will get? This plus you will get. This plus you will get. So how to simplify this? How to simplify this? Suppose I am having a transfer function like this. This is R of S. G of S. The output is C of S. The feedback signal is H of S. The negative feedback. The formula is C of S upon R of S, because Laplace transform of output upon Laplace transform of input equal to, what is in the forward path you have to see. What is the forward path? Suppose I am in Pondicherry. I want to go to Kadalur, means this is forward path. This is forward path. This is what? Going to Kadalur, then coming back to Pondicherry. Feedback path. Return back. So this is in forward path. What are the elements are there? Only G of S. That is in the numerator. Denominator, it should be, what is the closed paths? What are the elements in the closed path? G of S and H of S. Here minus sign is there. Therefore 1 plus. Minus sign is there. Therefore 1 plus G of S, H of S. G of S, H of S. Suppose plus sign is there. Then what is the formula? Then the formula is G of S upon 1 minus G of S, H of S. If it is plus sign is there, positive feedback means 1 minus G of S, H of S. For positive feedback means G of S divided by 1 minus G of S, H of S. This is the seventh rule. Only seventh rule you have to remember. All other rules are, you can understand by looking at the block. You can understand by looking at the block. Now, suppose I am having, these are all additional rules. Suppose I am having a summing block like this. How many signals are summed together? Q of S, E of S, R of S. All the three signals are summed up. How you can add all the three signals together? Suppose I am giving 3 numbers to you. How you will add? First you will add first 2 numbers. With that result, you will add the third number. The same concept. First 2 signals are added together. Then the third number is, or third signal is added together. So we can separate these two like this. The block diagram, we can separate the summing blocks like this. Similarly, if the 2 separate summing blocks are there, we can add it together like this. If you have the ability to add 3 numbers together, some people are like that. I've seen some videos. If you give 10 numbers together, they will add. We cannot. So points to be remembered while doing block diagram reduction. The block diagram consists of many feedback loops. Then find the innermost feed block. Many blocks are there. We cannot do all at a time. So we have to simplify one by one. You have to see the innermost block. First simplify the innermost block. Then if does not contain any takeoff or summing blocks, the inside that innermost block should not contain any takeoff or summing block. Then only you can add. Then third point is, if consists of any takeoff point or summing block, move that takeoff. That's why the rules we have seen. Move that summing block or takeoff point away from that block, then simplify that. That's all. The path consists of any cascaded blocks. Combine them using rule 1. If they have parallel paths, add together, second rule. Repeat the above steps. Algorithm. Repeat the above steps from 3 to 6 continuously. You will get a single block diagram. Now we will see this. This is 7 rules in nutshell. All the rules in nutshell. If the blocks are cascaded, you can multiply them. The blocks are parallel. Both are summed together. Both plus G1 plus G2. If you want to move the takeoff point from here to here, divide by G. If you want to move the takeaway point from here to here, multiply by G. If you want to move the summing point from here to here, the same rule. Here we are dividing because it is takeaway. Here we are multiplying, inverse. Similarly, if you want to move from here to here, the opposite to takeaway, divide by 1 by G. 7th rule, you know, G upon 1 plus GH. G upon 1 plus GH is the 7th rule. G upon 1 plus GH for negative feedback. If it is positive feedback, G upon 1 minus GH. That's all. Now, the another supplementary rules are, you can combine these two summing blocks together, or you can separate the summing blocks. That is the additional rules. You have to reduce the block diagram. The question may be like this: reduce the block diagram, or simplify the block diagram by using block diagram reduction technique, or find the transfer function C of S upon R of S by using block diagram reduction technique. You have to reduce the block diagram. The question may be like this: reduce the block diagram, or simplify the block diagram by using block diagram reduction technique, or find the transfer function C of S upon R of S by using block diagram reduction technique. So what is the first step? We have to look at the innermost part. This is the innermost part. In the innermost part, we cannot multiply these two blocks. Why? Because takeoff point is there. That's why we cannot multiply these two. So we have to move this takeoff point from here to here, so that or here to here, as you wish. You can do in both ways. Anything you wish can be done. So if you want to move this way, what you will get is, in the examination, you have to draw again the block. For each step, you have to draw the block again and again. G2, What second level? So here we have to move this block ahead of this point. Means what will happen? It is already amplified by G1, but it is not so if you move that. That's why we have to multiply by G1. G1, we can write G4 also like this because two blocks can be multiplied. That's all. Sorry. Then G3 is there. G3 is there. C of S and H1 is there. This is means this is unity feedback. Gain is unity, no amplification. This is minus sign. So these two can be multiplied together. That's why G1, G2 can be written. The next diagram, you have to write G1, G2. Now these two are in parallel. That's why we can write the another diagram. G1, G4 plus G1, G2. The feedback is there. Here, the next G3, H1, and another feedback is there. So now it is simplified like this. Now the innermost part is this. This can be simplified. Use seventh rule. We can write G3 upon 1 plus G3 H1. So this block is reduced. Now you will get one block here, another block here. That's all. Now, if you multiply these two together, let us call them as, you can multiply these two together. Let us call them G5. G5 equal to what? G1, G4 plus G1, G2 multiplied by G3 upon 1 plus G3 H1. This is G5. G5 is here. Feedback is unity feedback. Then what you will get? C of S upon R of S equal to G of S G5 upon 1 plus G5 multiplied by 1 because unity feedback. That's all. So now you know what is G5. This is G5. This is G5. Substitute G5 and 1 here and take LCM. You will get a single transfer function. So this is called a block diagram reduction technique. Okay, we'll see in the next class.